The following was recorded during a live Q&A session following Arnold's webinar, Optimizing Induction and Permanent Magnet Motor Design for Manufacturing. You can find the link to the full presentation, including 30 minutes of in-depth Q&A just like this, in the video description below.
Can you please comment on the best material for rotor magnet spacers? For example, wedges for bread loaf magnets. Aaron?
Yeah, sure. That's a great question. If we have spaces between the magnets, you typically, a lot of the time we leave that open. But if you do have, say, a high compression on the magnets from the sleeve, and you want a uniformly distributed pressure, say on your surface mount permanent magnets, there's a couple ways we can go about it. One is we can pot it with an adhesive, so we can fill that space just with a nice dense adhesive, which we can cure in place, and then obviously OD grind the adhesive and the magnets all at the same time, so we get a nice set diameter and a nice tight control. The other option is if you've got, say, maybe a carbon fiber sleeve, you want a really uniform distribution of the pressure on to the rotor, you can actually use what we call dead magnets. So you can use an unmagnetized magnet, but that's between the useful magnets that you're using, and OD grind that all at the same time, and that fills the gap with the exact same material, obviously, as your magnets. So that's the way you get really uniform, CTEs and a uniform pressure, from your sleeve onto your magnet. So a couple different ways: A, an adhesive, or B, you can use a dead magnet. Typically, we do not use metal spacers or anything like that. So probably most common are those two methods.
A bit of a follow-up here. Follow-up question regarding using dead magnets as magnet spacers. Is there a risk of these spacers remagnetizing to some degree and changing rotor flux?
That's a great follow-on question. We got to look at the field being placed onto the magnet, from the stator itself. So it's how much field are we applying to the magnet. So typically we're doing this with a really high coercivity samarium cobalt or a neodymium iron boron magnet. So there is, of the grains, the grain boundaries, the pieces of sand, I like to call them, that magnets are made of, some of those grain boundaries are going to have a very much lower coercivity, so they may take a bit of a field to them, but the majority of the magnet is a very high coercivity. We shouldn't be able to place that much field onto those magnets during operation and give them any sort of magnetization. But there's always going to be a very, very tiny degree of field imparted onto the magnet. But that's a really good question. That's something that we would work, our designers would work with our customers to scope all that out.